Hi, I'm Danny. Welcome back to the garage. Today, I'm going to show you a quick way to check the condition of an electrical component like a fuel pump or a fan motor. I'll do that by measuring the voltage drop across the fuse. Then I'll use that reading to estimate how much current that component is drawing. This is a quick test that'll help you find a failing component before it leaves you stranded. To show how this all works, I'm going to demonstrate this on the fuel pump circuit using two different Honda Civics with the same type of engine and original fuel pump. What I'm about to show you is the same procedure many technicians use to find a parasitic draw. The first vehicle I'll be testing is a gray Civic. It has 125,000 miles on it. And the second vehicle is a silver Civic with 175,000 miles. A 50,000 mile difference, and I expect to see higher wear indication on the Civic with 50,000 more miles. But let's find out. You're going to need a multimeter that reads millivolts, but don't worry, most of them do. We'll also check it with the amp clamp to see how accurate it is. Then we'll use the Amp Hound 2. This is actually made for what we're doing here. So make sure you stick around for the whole video. Let's get started. Locate the fuse that protects the fuel pump. On a 2009 Honda Civic, it's a 15 amp and it's fuse number 2. This is located inside the car under the driver's side dash area. Now start the vehicle, and with your digital multimeter on the millivolt scale, zero out your test leads. Then measure the voltage at each fuse test point and note the millivolt reading. Now I'm going to check my silver Civic. This car has 50,000 more miles, so I expect to see a higher millivolt reading. But let's find out. Once again, start the vehicle and put your meter on the millivolt scale. Then zero out your test leads. Now, go to the test points and read the millivolts across each test point. Write this down. Now that I have both voltage drop readings, I can convert this into current draw using a fuse voltage drop chart. I'll put a link to these fuse charts in the description in case you want to check your own readings. For the first Civic, I measured 25.4 millivolts, which works out to be about 5.5 amps according to the chart. And for the second Civic, it was 26 millivolts, which works out to be about 5.7 amps. Now the rule of thumb is that current should never exceed 75% of the fuse that's protecting that circuit. So my fuel pump was on a 15 amp fuse. 75% of that is 11.2. I was only reading 5.5 amps and 5.7 amps. That's well below the 11.2. So my fuel pumps are good. Now I'm going to check the fuel pump circuit using an amp clamp. So what I have here is I have a fuse adapter. So the fuse is going to come out. This part will go in the fuse. And then on this, these are two test ports. I'm going to put one lead here, one lead here. We're just making a loop. So we have something to put the amp clamp on. And then we'll run the car and we'll read the amperage. All right, so I'm going to start the car. I'm going to remove that fuel pump fuse, and the car should die if I did it properly. Perfect. Now I'm going to put my fuse adapter where that fuse was. Now I'm going to hook up my test leads. And now I'm going to start the vehicle. I'm going to bring my amp clamp over. I'm going to zero it out. There's 0, and then I just need to go over this wire here. And it should read my amps. 5.75. The amp clamp read 5.75 amps, and that's pretty much what I got when I did the fuse drop method and converted it with the chart. Let me show you another way to do it, and then I'm going to show you the Amp Hound 2, how that works. That's going to blow your mind. It does all the math for you. Now I'm going to use a multimeter. The only drawback is the circuit has to be under 10 amps. Otherwise, it may blow your meter fuse. So this time I'm going to take the red lead and we're going to put it in the amp scale. And then I need a black lead here. We're going to put it here. And this is going to go in the common area here. All right, and now I can just start it. I'm going to turn on the key and you're going to see an amp reading. And now I'm going to start it. And it's 5.72. That's pretty much what everything else is. Let's go ahead and use the Amp Hound now and see what we get. As far as setting up the Amp Hound 2, you just turn it on. And now you're going to select your fuse type. Right now it's on standard. And right now it's on mini or micro, and that's what we want. Now we want the fuse value. And we're at a 15 amp right there. And then I believe we push these two buttons. And once we get that, we're ready to go. All right, we got the 15 amp fuse back in. The Amp Hound is here. The car is running. So we just need to touch the test point and it should give me a current amp reading. So 5.7 amps, 5.8. That goes right along with every other reading. The Amp Hound, this is pretty awesome. Before I let you guys go, I want to know in the comments which method you thought was best. Also, if you end up doing this fuel pump test, I want to know the year, make, model, and the mileage on that vehicle. That's going to help me and others determine the condition of their fuel pump also. Hopefully this video was helpful. Now you know that you can check current to actually check the health of an electrical component. I'm going to put links to everything I used today in today's video in the description. The Amp Hound 2, I actually have a parasitic draw video that's really good. I think you should go watch that. I'll put that in the description along with a link to purchase this. These little fuse adapters, I use these all the time. These were really cheap too. And then an amp clamp. I have the amp clamp video and I'll put the link to this in the description along with the meter. And this is my go-to electrical kit. It pretty much comes with everything you need to do any electrical job. If you like this video, give me a thumbs up, consider subscribing. As always, thanks for watching and I'll see you in my next video.